So in this video we are going to discuss about null set. Null set. Okay. So null set is also known as empty set. Empty set or void set. Okay. So what is null set, empty set or void set? Okay. So a set is said to be null set or empty set or you can say void set if it has no element. For example, suppose we have a set of negative whole numbers. Okay, set of negative whole numbers. Okay, so what are the whole numbers? You see, whole number includes 0, 1, 2, 3, ... so on. Okay, so whole number starts from 0 up to positive infinity. Okay, so negative numbers are not included in the set of whole number. Okay, so that's why this set of negative whole numbers is empty set. Okay, this is an empty set. It is also represented by phi or empty brackets. Okay, hope you have understood this. Okay, let me clean this. So now our next topic is singleton set or unit set. Singleton set or you can say unit set. So what does unit set or singleton set mean? Okay, a set having only one element is called singleton set or you can say unit set. For example, you can say set of even prime numbers. Okay, so we know that there is only one even prime number, that is 2. So this set contains only one element, so that's why it is called singleton set or you can say unit set. Okay, so now let us discuss about finite set. Okay, so now you see a set containing finite number of elements is called finite set. Okay, so that means if a set contains countable number of elements, for example, set of vowels in English alphabet A, E, I, O, U, so we can easily count how many elements are there. There are 5 elements. Okay, so such kind of sets are called finite sets. Suppose if you take an example of set of all natural numbers, then you see all natural numbers, so 1 2 3 ... up to infinity, so it is not countable, it is uncountable, that's why it is not a finite set. Okay, so this kind of sets containing infinite number of elements are called infinite set. Okay, so what is infinite set? So what is infinite set? A set containing infinite number of elements infinite number of elements is called infinite set. For example, suppose set of all natural numbers 1 2 3 dot 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 dot, set of whole numbers 0 1 2 3 dot 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 up to infinity. Okay, those kind of sets are called infinite sets. Okay, so hope you have understood what is infinite set and finite set, null set, singleton set or unit set. So now let us solve some problems from exercise 1.2 of Ncert textbook of mathematics class 11. So this is the first question of Ncert textbook of mathematics class 11 of exercise 1.2. Okay, so here the first question is, which of the following are example of null sets? Okay, so there are 4 sets, 1 2 3 and 4. So which of them are null set or which are not? So here you see first one, set of odd natural numbers divisible by 2. Okay, so as we know there is no any odd numbers divisible by 2, that's why it is null set. So first one is null set. Okay, this is null set. Okay, and next one, set of even prime number. We know even prime number is 2. Okay, this is what? Even prime number. Even prime number. So that's why it is not a null set. Okay, so number 2 is not a null set. And the next one, x such that x is a natural number, okay, which is less than 5 greater than 7. Now you see a natural number, any natural number less than 5, that is 1 2 3 4, these are natural numbers less than 5 and they are not greater than 7, that's why it is also a null set. Okay, this is what? Null set. Next, x such that y such that y is a point common to any 2 parallel lines. Now you see, suppose we have 2 parallel lines. Okay, if they are parallel, if these 2 lines are parallel, then they should not have any common point, that's why this is also a null set. Okay, null set. So that's how we can answer the question number 1. So let's check what is there in the question number 2. So this is the question number 2. Which of the following sets are finite or infinite? Okay, so first set is the set of months. So spelling is mistake here. Set of months of a year. So we know in a year there are 12 months. Okay, so that's why it is finite set. Okay, it should be finite set as it contains countable elements. Okay, now this set, if you see this set, so this set is not ending. Okay, so it has infinite number of elements, so that's why it is infinite set. Okay, it is infinite set. This is infinite set. Okay, so now, so first one is finite set and second set is infinite set, and third one, here you see this is ending at 100, starting from 1 and ended at 100, so that's why it is a finite set. This is a finite set. And the next one, set of positive numbers greater than 100. Okay, set of positive numbers. Okay, there are infinite number of positive numbers, and here you see greater than 100 also there are infinite number of positive numbers which are greater than 100. Okay, so that is also infinite set. This here you see this number 4, it is also infinite set. This set is infinite. Okay, so next one, set of prime numbers less than 99. Okay, generally set of prime numbers is not finite set, it is infinite set, but when it is said that less than 99, so it must contain countable number of elements, so that's why it is finite set. Okay, so that's how we can solve question number 2. Now let's move on to next question. So this is question number 3. Okay, let me show you how to solve this. State whether each of the following sets are finite or infinite. Okay, it's similar to question number 2. So what is the first set here? So the set of lines, okay, this is set of lines, sorry for this. Okay, set of lines which are parallel to x-axis. Okay, now you see set of lines parallel to x-axis. Suppose this is a coordinate system x, this is y, so we can draw infinite number of lines which are parallel to x-axis. So that's why this first one is infinite set. Okay, and the next one, so what is the next one? The set of letters in English alphabet. So we know there are 26 alphabet in English, so that's why it is finite. Okay, this set is finite set. Okay, the next one, the set of numbers which are multiple of 5. As there are infinite number of multiples of 5, that's why it is infinite set. Okay, now set of animals on the earth. Okay, there are infinite number of animals on the planet earth, so it is infinite. And in the last one, here you see set of circles passing through the origin O. Through any point, there are infinite number of circles can be passing through one single point. That's why through the origin also infinite number of circles can be passing through. That's why this set is also infinite set. Okay, so that's how we can solve question number. So here you see this is the question number 4. In the following sets, whether A is equal to B or not. Okay, first we have to compare those sets here, and we have to check these sets are equal or not. Okay, so now you see, first of all, the first pair here, set A is what? Set A contains small a, b, c and d, and set B also contains a, b, c and d, but orders of the elements are different, but both the sets contain same elements and same number of elements. That's why A is equal to B in this case. Okay, so in this case A is equal to B. Okay, so now next one, here you see this contains 4, this also contains 4, and this contains, set A contains 8 and B also contains 8. A contains 12 but B doesn't contains 12, so that's why A is not equal to B in this case. So here you see A contains 2, 4, 6, 8, 10. Okay, And here set B is what? X such that X is a positive even integer. What is this? Positive even integer less than equal to 10. So positive even integers less than equal to 10 means it may be equal to 10 and less than 10. So 10 is even number, so 10 is included, then there will be 8, then there will be 6, then there will be 4, then there will be 2. So here you see, if you compare these two sets, so we will get A is equal to, sorry, here A is equal to B. Okay, in 3 A is equal to B. Now here you see set A is what? X such that X is a multiple of 10. But here you see in set B, 15 is not multiple of 10, 25 is not a multiple of 10. That's why in this case A is not equal to B. Okay, so hope you have understood this. So let's move on to next question. So this is question number 5. Are the following pair of sets equal? Give region. So we have to check that these pairs of sets are equal or not. So there are two sets. Here you see set A and B. Here also A and B. We have to check they are equal or not. If they are equal, we have to give region. So here you see first pair, in the first pair, here A is 2, 3. Okay. So in order to find the elements in set B, so we have to solve this equation. Okay, because here it is given that set B is nothing but what? X such that X is a solution of this equation. So let me show you how to solve this. This is a quadratic equation, so you can easily solve it by factorization method, or you can use quadratic formula as well. So I am using here factorization method. Okay, so x square plus, so it can be written as thrice x plus twice x plus 6 is equal to 0. Then so from these two we can take x common, then we will get x plus 3, and from these two we get 2 common, so x plus 3 again equal to 0. So again x plus 3 can be taken as common, so here x plus 3 into then x plus 2 left, so this is x plus 2 equal to 0. Both of them equal to 0. So what does it mean? It means either x plus 3 is equal to 0 or x plus 2 is equal to 0, and these two implies that x is equal to minus 3 or x is equal to minus 2. Okay, x plus 3 equal to 0, that means x is minus 3. X plus 2 is equal to 0, that means x is equal to minus 2. So that means the elements in set B should be minus 3 comma minus 2. That's why these two sets are not equal. Okay, sets A and B are not equal in this first pair. So now let's move on to the next pair. Okay, here you see what will be the elements in set A. So set A is given that x such that x is a letter in the word follow. Okay, and so that's why A must be equal to what? F O L W. Okay, so we don't write the same letter twice. Okay, so this is follow, F-O-L-L-O. So there are two L's, but we are writing here one, because when you write the sets of the letters in a word, we don't use the same letter two times. Okay, then now also given that B is equal to what? Y such that Y is a letter in the word wolf. Okay, what is the word? Wolf. So what will be the elements in set B? Here W O L F. So if you compare these two sets, you can see all the elements set A are contained in all the elements set B, and in both sets same number of elements and same elements are there in different order. So that's why, so order of the elements doesn't matter here. Okay, just we need to check, so same elements are contained in both sets or not. Okay, so that's why here you see A must be equal to B, because both A and set B contain the same elements. So that's how we can solve question number. So this is question number 6. From the sets given below, select equal sets. So we need to select the equal sets. So first set is 2, 4, 8, 12. A is equal to 2, 4, 8, 12. So is there any set which is equal to this set? Let me check. So C contains 4, 8, 12, 14, but A doesn't contain 14. So A and C are not equal. Then B contains 1, 2, 3, 4. Is there any sets containing 1, 2, 3, 4? Yes, this is 1, 2, 3, 4. That means these two sets are equal, set B and D. Okay, both contains same elements. Okay, so we can say set B is equal to set D. So here you see set E contains -1 and +1, and set G contains +1, -1, same elements but in different order. So we can write E is equal to Z. Okay, so E is equal to Z. Then let me check more sets. Okay, so if there is 0, A, is there any other sets containing 0, A? No, this is 0, 1, not A. Okay, so we have only these two pairs which are equal. Okay, these two pair of sets are equal, B and D and E and Z. Okay, so set B equal to D and set E is equal to Z. So hope you have understood this.